Hello again, grade 8s. In today's lesson, we are going to look at linear equations and talk about what a linear relation is, and then use a linear equation to actually plot points on a graph by constructing a table of values. So let's start off with another definition. This time around, we're going to look at what an equation is in mathematics. So we're just going to distinguish this between an expression and an equation. So an expression in mathematics is a statement that has a combination of operations, variables, numerical coefficients, and constants. An equation is also a mathematical statement, but this time around it actually has two expressions inside of the statement, and they're separated by an equal sign. And if the two expressions are separated by an equal sign, it tells you that the two expressions have the same value. Okay, so here's some examples of what an equation might look like. You have 3a plus 5 is equal to 4. So 3a plus 5, that's one expression. And then 14 would be another expression. So if you have 3a plus 5 and 14, and they're the same value, we can put an equal sign between them. So the dead giveaway you're looking at a mathematical equation is that you have an equal sign in it. I mean, just look at the first four letters of the word equation. The first four letters of the word equation would actually spell out equal, okay? So equation is going to have an equal sign. Other examples might be 6s minus 10 is equal to 4s plus 20. So once again, that's one expression, 6s minus 10. 4s plus 20 is another expression. And if they're the same value, we can put an equal sign between them, and that makes it an equation. Or, and this is the equation we're going to look at more so in this lesson, we can actually have two variables in an equation compared to just one variable. So if all these ones only had a single variable, this equation only had the variable a, this one only had the variable s, this one actually has two variables. So your one expression on this side would be y, and your expression on this side would be 2x minus 1. Okay, and we're going to focus on that, specifically that kind of an equation. Now, the main emphasis of this unit is dealing with linear relations. So let's also give a definition for what that would be. A linear relation is a pattern made by a set of points that lie in a straight line. So let's say that you collected some data and then you decide to plot this data on an axis, like a y-axis. This would be like the y-axis. This would be the x-axis. If you can actually take a straight line and you can fit them through all those points, that's what we refer to as a linear relation. And again, if you look at the first four letters of the word linear, okay, a linear relation are relations where you can take a straight line and put them through the points formed by whatever the pattern made by a certain set of points. Okay, so that's what we're going to look at. We're going to look at relations where specifically we can actually put straight lines through them because they're the most simple type of relation to start off with. And then as you go into future mathematics courses, you start to look at relationships that are a lot more complicated, where they have like curves to them as opposed to just being straight lines. Okay, and yeah, you can put a straight line through that. Okay, so example 1 says, use the linear relation y is equal to 2x minus 1 to A, complete the table of values, B, graph the ordered pairs formed in the table of values, and then C, use the equation to figure out what the value of y is when x is equal to 50. Okay, so here's how we go about doing this. So we're going to first of all write down our equation. So our equation here is y is equal to 2x minus 1. Now, what I'm going to do is in the table, I have a bunch of different values of x. I have x is -2, x is -1, x is 0, x is 1, and then x is 2. What I'm going to do is a substitution. So I'm going to take, for example, x equals -2, and I'm going to plug it into this equation for x, and then figure out what the value of y would be equal to. So let's go ahead and do this and see what this would be. So this would be if, we can say here, if x is equal to -2, and then if you plug this into the equation, it'd be y would be equal to 2 multiplied by, okay, in the place of x, we're going to place x with the value -2 here. And then we're going to subtract 1. So all I've done is, in the place of x, I'm replacing it with -2. And remember, when we do substitutions into equation, it's more common, the way we want to substitute numbers into the equation is with brackets. And then a number beside brackets means we're going to carry out multiplication. Okay, so let's do this now. So this would be equal to 2 times order of operations. It's telling me to do the multiplication first, then the subtraction. So 2 times -2 would be -4. And then we've got to still subtract that 1 at the end. And then -4 minus -1 would be -5. So my table of values up here, when x is -2, y would be evaluated to be -5. And I can form an ordered pair off of this. So the ordered pair would be 2, -5. Okay, now we're going to continue to do this process with different numbers. So now what I'm going to do is I'm going to go back to the same equation, except this time around I'm going to plug in x is equal to -1. Okay, so we're going to plug -1 into this equation up here, then evaluate it. So this would be y is equal to 2 times, now this time around, the value of x is -1. So we'll plug in -1 here, minus 1. And that would be equal to, well, 2 times -1 would be -2. Subtract 1 would be equal to, -2 minus 1 would be -3. So in the data table, we can put in -3 here, and then my ordered pair would be -1, -3. Okay, we'll keep going. Now we're going to have a value of x of 0. So if x is equal to 0, let's calculate this. So this would be y would be equal to 2 multiplied by 0 minus 1. 2 times 0, so again, what I'm doing is I'm just replacing x with 0 this time around. So 2 times 0 would be 0 minus 1 would be equal to 0 minus 1 would be -1. So I'd have 0, -1, write that as an ordered pair, and you'd have 0, -1. Okay, let's keep going. So what if x is 1? Okay, so if x is 1, let's plug this in. So 2 times x, but this time around x is going to be 1. That's why it's called a variable, by the way. So the variable x means it can be a changing value. So we're plugging in different values for what x can be. Then y is also a variable because we're getting different values for y depending on what the value of x is. Okay, so 2 times 1 minus 1 would be, 2 times 1 is 2, minus 1 would be equal to, 2 minus 1 is just going to be 1. Okay, so positive 1. The ordered pair would be 1, 1. And then the last one we have is x would be 2. So that's going to be y is equal to 2. This time around, we're going to replace the x with 2. So 2 multiplied by 2 minus 1 would be equal to 2 times 2 is 4. Minus 1 would be 4 minus 1 is 3. Okay, so here you'd have 2, 3. Now, I want to take these points and I want to plot them on this grid. So this is my y-axis and this is my x-axis. Okay, so -2, -5, we plot by starting at the origin and going 2 to the left, and we go 5 down. So this first point is going to be, oops, did not seem to like me doing that. We'll make it right here. what happened there. Okay, the next point is -1, 3. So we go 1 to the left and then 3 down. So that's going to be located here. Again, I just kind of got to draw a bunch of little tiny dots here because the actually that's working. Weird things when you try to use a drawing tablet. Okay, then we have 0, -1, which means starting at the origin, don't go anywhere left or right, just go down to -1. So that would be a point that's right here. Okay, and then we'd have 1, 1. So that'd be go to the right by 1 and then up by 1. So this point would be located here. And the final point would be 2, 3, which means go to the right by 2 and then go up by 3. So my final point is going to be located up here. Okay, so here are my 5 points. Now, is it a linear relation or not? Well, we can confirm that if we just see if we can draw a straight line through it. And I can draw a straight line through it. So I'm just going to just go here for a moment. And then I'm going to insert a line. There's absolutely no way I can draw a straight line with the drawing tablet. So I'm going to cheat and use a clip art or use a shape to do it. Okay, so let's go here. Let's pick a line. Okay, and I want to try to draw a line here. And my line seems to have disappeared. Okay, let's see if I can do this. It doesn't want me to do it with the drawing tablet, of course. Okay, so let's take this line. And let's make it so I can actually see it. So let's make it like, I don't know, let's do blue. Make it really bold. This is much easier for you to do because all you have to do is just take a ruler and just put it straight to the points. So that should be simple. Okay, so let's try to get it through. It goes through all these points here. So let's move this over. Okay, that's pretty good. Okay, now when I draw the line here, I'm going to make it span the entire graphing area. So I'm going to make it go all the way like across. So let's see if I can get it to go right there. Good. And then we'll go down. We'll go right there. Yeah. So if I go back to the slide now, yeah, that's a line that nicely fits through those points. Okay, second example says use a linear relation y equals -x plus 4 to do the same thing again. Oh, we didn't finish part C here. Sorry. Yeah, let's do that first. Okay, so this was part A. Okay, part B was plotting the points and drawing a line through it. And then part C says calculate the value of y when x is equal to 50. So we can actually just use the equation again to do that. So for part C, we're just going to plug in y. We're going to write down x is equal to 50. And then we're going to go y is equal to 2, replace x with 50. And then minus 1. And then 2 times 50 would be 100. And then minus 1. So 100 minus 1, your value of y would then be equal to 99. Okay, let's go to the next example. Okay, so it says use the linear relation y equals -x plus 4 to, again, just do everything we just did in the previous one. So, okay, so let's complete the table of values. We'll do the same thing again. So let's write down this equation. So And by the way, if you don't see any number in front of this x here, it's implied to be a 1. So you can basically just write down y is equal to negative 1x plus 4. Okay, now we're going to fill in the table of values by plugging in different values of x and seeing what y is equal to. So this is going to be part A. Okay, so if x is equal to negative 6 is our starting point, then y would be equal to negative 1 multiplied by negative 6 plus 4. Negative 1 times negative 6 plus 4. So negative times a negative is a positive, so that would be 6 plus 4. And then that would be equal to 10. Okay, if we write the order of pair down, it would be negative 6, comma 10. Okay, then we're going to plug in x equals negative 3. So x equals negative 3. So my equation y would be equal to, so you have negative 1. Plug the x in with negative 3. And we're going to add 4. So negative 1 times negative 3 would be positive 3. So you have 3 plus 4 would be equal to 7. So you have negative 3 comma 7. And then 0. Okay, so that's going to be equal to negative 1 times 0 plus 4, which would be negative 1 times 0 is 0, plus 4 would be equal to 4. So the value of y here is 4. So that's going to be 0, comma 4. And then if x is positive 3, plug it into the equation. So you'd have negative 1, replace x with positive 3, plus 4. Negative 1 times 3 would be negative 3, plus 4. Negative 3 plus 4 would be positive 1. And then my last one would be when x is 6, you'd have y is equal to negative 1 times 6 plus 4. Negative 1 times 6 would be negative 6. Add 4 to it. If you're at negative 6 and you go up by 4 on a number line, you'd be at negative 2 then. So we can fill these points in. So this would be 1. This would be negative 2. So this ordered pair would be 3, comma 1. This ordered pair would be 6, comma negative 2. Okay, that's part A. We have the table of values plugged in. Now part B is we're going to plot all these points on the graph and see if it's a linear relation. So negative 6, comma 10 would be go 6 to the left and then 10 up. So that's going to be a point that's going to be located up here. Negative 3, comma 7 goes 3 to the left and then 7 up. So that's going to be about right here. Okay, and then we have 0, comma 4. So it means start at the origin, just go 4 up. So that's going to be located here. And then we have 3, comma 1. So go 3 to the right and then 1 up. So that's going to be located at this point. And then we have 6, comma negative 2, which is go 6 to the right and then 2 down. So that's going to be located right here. And again, can we put a straight line through it? Again, let's try to get like a clip art or a shape to actually put through it. I mean, again, you can just pull out a ruler. And by the way, you absolutely should use a ruler to draw lines. So I'm just going to go here. I'm going to copy this line because I don't want to redraw it completely. So we'll go back to this slide. Let's paste that line. Okay, and I'm going to get this line just to see if I can fit it through these points. And if it is, it's a linear relation. Okay. How's this? That's pretty good, okay? And then I can make it span the graphing area. So just make it go all the way through down to the bottom, okay? And so that is a linear relation because a straight line can go through it. Okay, part C, let's not forget it this time. So part C says determine the value of y in the ordered pair -100, y. Okay, so what this is telling you right here is it's telling you that the value of x is -100, and it wants to know what the value of y is. This is almost identical to what we did in part C from the previous example. So for this, we're going to sub in x is equal to -100. And then we're just going to evaluate the equation for x is -100. So that's going to be y is equal to -1 times -100. And then we're going to add 4. -1 times -100 would be 100. And then add 4 to that. And then we're going to get a value of y that would be equal to 104. Okay, last example. So it says use the linear equation y equals 2 minus 3x to complete the table of values by using positive and negative integers and 0 for the value of x, and then graph the order pair from the table of values. So the only additional complication here is it doesn't tell you which values of x to choose. Now it does say pick negative and positive integers and 0. So I think the easiest thing to probably do right here would be try to make this symmetrical. So in the middle of the table, I'm going to pick 0. And then basically from 0, we can just go up and down by 1 in each direction. So here we can go to +1 and then +2. And then here we can go to -1 and we can go to -2. And then what I want to do is I want to evaluate this. So y is equal to 2 minus 3 times x, and I'm going to do it for these 5 values of x. Okay, so if x is equal to -2, we're going to replace x with -2 in this equation. So it would be y is equal to 2 minus 3 times -2. Now you got to be careful with the order of operations here. So in this case, the multiplication is actually on the right-hand side first. So we're actually going to do this before dealing with the 2 minus. So that's going to then be, okay, so it'd be 2 subtract 3 times -2 would be -6. Okay, so then what you have is 2 minus -6. Well, when you subtract a negative integer, it's the same thing as adding a positive one. So we're actually just going to add those two numbers together. So that's going to give me a value of y that would be equal to 8. Okay, so I have -2, 8. Let's do this for the next value of x. So that's x equals -1. So that would be y is equal to 2 minus 3. In the place of x, we're going to do a substitution or place it in brackets with a -1. And again, I'm going to watch the order of operations here. So we're going to do the multiplication first, which is going to be the 3 times the -1. Okay, so that would then be 2 subtract, okay, 3 times -1 would be -3. Then once again, when you subtract a negative integer, it's the same thing as adding a positive one. So we'll just correct those signs. And then I would get 2 plus 3 is going to be equal to 5. Okay, x equals 0. Plug it in. You'd have y is equal to 2 subtract 3 multiplied by 0. And again, order of operations. So we need to do the multiplication before the subtraction. So this one's easier though, because you're just going to go 2 subtract, well 3 times 0 is just 0. And then 2 minus 0 would just be equal to 2. So you got 2 up here. This one was a 5. -1, 5, 0, 2. Okay, and then x is equal to 1. So then I'd have y is equal to 2 minus 3 times, replace the x with a 1. So then this would be 2. And again, order of operations. So we're going to go the 3 times the 1 here. So 3 times 1 would just be 3. So you're going to go 2 minus 3. And this would be equal to -1. So my point would be 1 comma -1. And the final point would be x equals 2. Then you'd have y would be equal to 2. Subtract 3 times 2. 2, subtract, again, order of operations. Got to do that multiplication before the subtraction. So 2 minus 6. 2 minus 6 would be -4. So we got -4 up here. We'd have 2 comma -4. Okay, that's part A. Part B, we're just going to plot these on the graph and see if we get a linear relation. So the first point would be go to the left by 2 and then up by 8. So 2 to the left, up by 8 would be located here. Okay, second point is go to the left by 1 and then up by 5. Okay, next point would be starting at the origin, just go up by 2. Next point, 1 comma -1, so go 1 to the right and then 1 down. So it's going to be located here. And then 2 comma -4, 2 to the right and then 4 down would be located right there. Okay, let's see if we can get a straight line to go through this. So I'll just exit here and I'll copy that, that shape again. So let's copy this line. Okay, and then let's paste it here and see if I can get that line to go through all these points. I'm going to have to change the slope or the steepness of the line. Okay, and then, yeah, that's looking pretty good. Again, much easier for you to do if you just use a ruler. You don't have to try to manipulate a shape in PowerPoint to actually get it to do it. So yeah, it is a linear relation because you can fit a straight line through it. Okay, that's it for this lesson. In the linear relations workbooklet, you can complete the assignment called Graphing Linear Relations, where you're just going to do a lot of problems just like we did in the examples, where you're going to be given an equation. You need to complete a table of values by evaluating for different values of x, plotting the data, and then you might have a follow-up question that asks you to figure out what the value of y is for like a much larger value of x. And I'll talk to you in the next lesson.